Just before we start this video, if you have any questions at all, you can leave them in the comments section down below and I'll get back to you as soon as possible. So for the first few questions, I'm going to go quite slowly through them just to explain the basic principles of indices, and as we progress to slightly harder questions, I'll ignore the basic stuff and just explain the key points for each question. Okay, so starting with question 1, we need to write 3 times 3 times 3 times 3 times 3 as a single power of 3. So a power of 3 just means that the base, which is the number which is being raised to a power, the base is going to be 3. Okay, and for this question all we have to do is count how many 3's there are here. So as there are 5 3's, we can say that it's just 3 to the power of 5. And this is because 3 times 3 is equal to 3 squared, and then times 3 again, we get 3 cubed, and so on. So 3 to the 4 and 3 to the 5. So the final answer this question is 3 to the power 5. So for part B, slightly different, we need to learn one of the rules here, which is when we've got a base, which is in this case 7, multiplied by another base, and we have 2 powers, what we have to do is we have to add these 2 powers together. So the important thing is the base must be the same. If the base isn't the same, say if this was a 6 here, we won't be able to do this, but as it is the same, we can therefore rewrite our question as 7 to the power of 14, and this is over 7 to the power of 6. Now I'm going to rewrite this as 7 to the power of 14 divided by 7 to the power of 6, exactly the same, just a different format. This is a second rule now, so when the base is the same, in this case 7, and they're being divided by each other, what we do is we take the 6 away from the 14. So the final answer for this question is 7 to the power of 8. So we've got 2 rules here. We've got the multiply and the division. So when it's multiply and the base is the same, we add. When it's divide and the base is the same, we subtract. Okay, question 2a. It's the same rule again, the multiply rule. So we just add the 2 powers together this time. If my pen wants to work, there we go. So this is equal to 2 to the power of 3 plus 6, so 2 to the power of 9. Okay, part B, I'm going to rewrite it in this format just so that it's really clear what we're doing. So this time it's divide, so we need to subtract the 2 powers, so this is equal to 3 to the power of 5. Really simple. Part C, this time it's a bit different because on the top of this fraction we've got 5 to the power of n, and for the question we need to calculate the value of n. So what we need to do for this question is, you might think, I don't know where to start, but just do what you can. So we know how to solve the bottom as the base is the same and they're being multiplied. So all we have to do for the bottom is we just need to add the 2 powers. So we can rewrite our question as 5 to the power of n all over 5 to the power of 4 plus 6, which is 10, is now equal to 5 to the power of 3. Okay, we now need to rearrange our answer down here to get 5 to the power of n to be on its own on one side of the equal sign. So to do this, it's just like linear equations. All we have to do is multiply both sides by 5 to the power of 10. Okay, so when we multiply both sides by 5 to the power of 10, we are left with 5 to the power of n on the left, and 5 to the 3 multiplied by 5 to the 10 on the right. From this point, we've got a base and a base that's the same, being multiplied, so we just add the 2 powers together. So we're left with 5 to the power of n is equal to 5 to the power of 3 plus 10, which is 13. And just from observation, we can see that the n on the left hand side has been replaced by 13 on the right hand side. So therefore we can finally say that n is equal to 13. Okay, question 3 part A. We've seen this one before, different numbers, but we've seen this kind of question before, so I'll just go through it quickly. Base the same, so we add the powers, so this is equal to 2 to the power of 7. Question B, a bit different. Again, we have an unknown, 2 to the power of the n here. So again, you might not know what to do, but just do whatever you can. So 5 times 7, we know how to do that. So we can now say that 280 is equal to 2 to the power of n multiplied by 5 times 7, which is 35. We can then divide our 280 by 35. So 280 divided by 35, that gets us 8. So we've now got 8 is equal to 2 to the power of n. Okay, so this time we can't tell from observation what n is equal to. Let's not rub that out, because we've got a base of 2 here and a base of 8 here. So for this question we need to think a bit outside the box and realise that if we have 2 squared, that is equal to 4, but 2 cubed is equal to 8. So we can rewrite our 8 here as 2 cubed. So you've just got to spot this. Sometimes you will get questions like this where you've just got to try and spot any patterns you can. The big hint is we've got a base of 2 here, so we need to try and get this number with a base of 2, as in 2 cubed. So we've now got 2 cubed is equal to 2 to the power of n, and therefore from observation we can say that 3 is equal to n, or n is equal to 3. Okay, part 4a, part 1, we need to simplify, leaving our answer in index form. Again, we've seen this kind of question before, so we just add the powers together, so we get 7 to the power of 8. Part 2, again seen it before, we just subtract the 3 from the 9, so we get 5 to the power of 6. Part B, again we've seen this kind of question before, apart from this time the unknown is on the bottom of the fraction. So the first thing to do is well, there's 2 things you could do first. You could either solve this, or we can multiply both sides by 2 to the power of n. I'm going to multiply both sides by 2 to the power of n first of all. So we have 2 to the power of 9 multiplied by 2 to the power of 4 is now equal to 2 to the power of 8 multiplied by 2 to the power of n. Okay, next step, we need to solve the left hand side. So we have 2 to the power of 9 plus 4, which is 13, and this is now equal to 2 to the power of 8 multiplied by 2 to the power of n. Okay, we then need to get the unknown term to be on its own on one side of the equal sign. So to do that, we're going to divide both sides by 2 to the power of 8. So we have 2 to the power of 13 divided by 2 to the power of 8 is equal to 2 to the n. And we just solve the left hand side by subtracting the powers. So we have 2 to the power of 5 is now equal to 2 to the power of n. And from observation we can say that 5 is equal to n, or n is equal to 5. I hope this video was useful, and if you've got any questions at all you can always ask me in the comment section down below, or alternatively you can contact me on Instagram via DM and I'll be sure to help you out there. Don't forget to subscribe as well and turn on channel notifications, and then you will never miss an upload in the future. And of course I upload daily on Instagram as well as TikTok, and if you want more maths content be sure to follow me over there.